Hello everyone, my name is Vishnu and today we are going to be building a physics module in Python. And yes, I know that physics is perhaps the most vast of the sciences, covering everything in the known universe, literally everything. So it would be nearly impossible to build a Python module that covers everything in physics. So for this video we will be focusing on high school physics equations. So after building this module, I'll be showing you all how you can post your own modules to pip, which is a package manager, so that other developers can use the functions we create in their Python projects. Okay, so before we get started, I would like to quickly emphasize that this is not going to be a tutorial, right? I'm not going to show you word by word what to type to build your own physics module. I will be giving a tutorial at the end, or a mini tutorial, on how you can publish your own libraries or modules to pip so that other developers can access those functions. But this is not going to be like word for word. So this is because the best way to learn and strengthen your Python skills is to build projects on your own instead of following a tutorial. So it's good to use tutorials and documentation to learn the basic syntax. But once you have that down, you do need to build projects on your own to learn the language itself. So I'm making this video to kind of document my creation of the module, discuss some challenges I experienced throughout the process, and kind of discuss how I planned the entire thing out. So before starting the physics module itself, I do want to quickly discuss the purpose of modules in Python, but if you already know what modules are, then you can skip to the timestamp on the screen. Okay, so if you're still here, you want to learn more about modules. When we downloaded the Python language, the language itself comes with the standard library. So the reason we as humans go to the library is to rent books, which we read to get knowledge, which we use to enhance our capabilities and functionalities. And I know I'm speaking about humans as if we're all robots who want to enhance our features, but for the sake of understanding the Python standard library, we can simplify this logic and state that we go to a library to increase our own functionality. Similarly, in Python, we use the standard library to enhance the capabilities of the language and the syntax. So as you can see, this is the documentation of the Python standard library, which outlines all of its core features. The standard library allows us to use Python syntax to interact with our operating system, manage files, and even perform mathematical calculations, as you see here. So each of these categories of functionalities are called modules. So think about each module, like import RE or math. Think of each module as a book in a library. Now, books in real libraries, like physical ones, have specific chapters, and each of these chapters discuss some unique topic. So similarly, all of our modules in the standard library have various functions that all perform different tasks. So how do we use these functionalities in our own code? Well, in order to enhance the functionality of our Python syntax that we are using, we need to use the standard library, right? And we need to use a specific keyword called the import keyword. So if we open up whatever text editor you want, in my case, Visual Studio Code, we can open up a file, navigate to our programming folder, and open up whatever file we want to develop on. In this case, my module is going to be named PySix. See what I did there? But we're going to be using that for development today. So if we open up a new file, just call it test.py, because this won't be our actual physics module. Instead, we'll be working with just understanding the import keyword just a little bit more through this small exercise. So in order to enhance the syntax that we are using in Python, we use that import keyword. And as long as the module or the chapter is a part of the standard library, it's already downloaded on our computer. So if you downloaded Python from that python.org website, you are all set, right? You have the standard library. From there, all you have to do is import that specific module or modules into your code in order to use it. So if you went back to the documentation, you could see that there was a module called math. So the math module allows you to perform mathematical calculations in your Python code. Okay, so if we say import math, we can see that now we have the math capability on our computer. So we can use this in our code now. We can say math dot, and then the moment you put dot, you get IntelliSense. So let's say we want to find the sine of something, or rather the square root. Let's start with that. And we say the square root of 64. And let's say we want to print this out. If we go to our integrated terminal and say Python 3 test.py, we get 8, right? So 8 tells us that that is the square root of 64. So we can use this math function in order to perform mathematical calculations. Okay, so now that we have a basic understanding of these modules, or at least the ones in the standard library, we need to start talking about third-party modules. So apart from those included in the standard library, there are other modules that can be used in Python, and we call those third-party modules. These modules are usually created by individuals to help other programmers simplify certain tasks. So third-party modules are essentially just a list of functions that can be used or published to simplify the process of creating a specific program. So in my case, I'm building a module to help other developers build physics-related programs. Therefore, my module needs to have basic physics equations pre-built. For example, instead of having to calculate force through the expression mass times acceleration, I just need to create a function, maybe called calcForce, that allows a programmer to simply pass the mass and acceleration as parameters, and it outputs the result. Now, if functions and parameters are completely new to you, I will briefly explain those concepts as we actually start building the program. I plan on releasing a Python basics video in a couple weeks that will cover everything from variables to loops to functions, so stay tuned for that. Anyways, the last thing to understand about third-party modules is where we can import them from. So since the standard library is just installed alongside Python, we can just use the import keyword in the Python program and we can utilize any standard module. However, third-party modules are not included in the standard library because, well, they were created by third parties. So to use a third-party module in Python, we need to download the module separately since it doesn't piggyback alongside the Python download, just like the entire standard library does. So in order to separately download a module, we use pip, which stands for pip installs packages. Yes, I know they're literally using the acronym in the definition of the acronym. That is called a recursive acronym when the acronym refers to itself. So anyways, pip manages packages. So pip allows us to install third-party modules, and creators of these modules can publish their packages through pip, which allows other programmers to easily install their modules. So just as an example, if we open up your terminal, in my case, iTerm, and we want to download some third-party module. So this example will use Selenium. Selenium is a suite of tools that can be used to automate testing across different browsers. So Selenium is a great example of a third-party module in Python. To install it, we simply open up the command line and type in the keyword pip install and then Selenium. And if you wait a second, it collects all of those packages and then says successfully installed Selenium. Okay, so that was a mini tutorial on modules in Python. So let's get started planning out the module I am planning to create to help programmers integrate physics equations in their code, whether it be for research, projects, or just for fun. So here I have outlined all of the requirements for my Python physics module. We see the list of equations I want to include right here, as well as all the constants that should be automatically stored. These equations are going to be a function, but first we can group them into categories just for organizational purposes. First of all, in order to get these equations, I just flipped through my old high school introductory to physics notes and wrote down all the formulas and rules we learned in class. Just as a disclaimer, I go to a school that follows the International Baccalaureate program. Therefore, there isn't a list of formulas from AP Physics or anything like that. This is just a list of formulas from my Intro to Physics class in the middle years program, so nothing too crazy. So the first category of equations is motion. Anything in this blue color is a constant, while everything in a black color is a formula. I won't go through every formula, just the categories, but please let me know in the comments if you're confused about any of these specific formulas and I can help you out with those. So next up we have friction right over here, which mainly deals with static and sliding friction right over here. The coefficients of friction have different values for different materials, so those constants will represent a few of the common constants that a physicist would need to use in their research when it comes to frictional constants. So here you can see the static coefficient of friction for rubber on dry concrete and other common materials and their coefficients of friction for both in the static state and also a kinetic or sliding friction state. Next up, we have linear motion, which are our basic kinematic equations. And after that, we have momentum and impulse, projectile motion, circular motion, universal gravitation, electricity, work and power. That's pretty simple. Power is just the rate at which work is done, and some other introductory physics equations. So we need to convert all of these into functions, which is the hard part, actually programming these formulas into a Python library. So let's get started. Okay, I think I've finished all the equations I was planning to finish for this entire library, so as of now it's done. So next up, we need to figure out how do we upload it to pip. But before that, let's go over what I've created right here. So this is going to be a complete overview of this physics module, which again, I decided to call PySix because, you know, the pun. So we have all the equations as functions with options for user input depending on the formula. All of the constants are listed as predefined variables for anybody who wants to import the library, because I don't think you can really create constants in Python. So I've just used variables, and then once you import the library, then they function as constants. Okay, so now we're going to publish it to pip. There's a couple files that you do need to install on whatever set of functions you want to upload to pip. So if you're creating a module alongside this and just want to understand how you publish to pip and allow other developers to access your functions, then this is the spot to start at, right? So the first thing we need to do is we need to write a readme.txt that basically has a simple description of what your module does. In this case, mine is a simple physics module for Python, obviously, with introductory physics equations. Okay, afterwards, we need to create a manifest.in, which basically says what files should be included. So anything that ends in a .text or .py will be included, which is my setup.py and init.py. So I did create a separate folder called PySix, and within that have my library, and rename my library to init.py. So once you do that, create that folder just to keep everything organized. We do need to come up with a change log. So a change log is basically where you update whenever you add a new version of your module. You update, this is where you keep your release notes basically. So on your second release, you type what all you changed, why you changed it, and what the new features are. So after you finish that, the final thing I believe is your license. Yep. So your license, oh yeah, and then there's setup. Okay, so your license is basically coming from, in this case, MIT, right? And they're the ones giving you a copyright, basically saying that this is your module, and it's called an open license. So if you go to open license MIT and search that up. You can click over here and just from here to here, copy it and replace a year and with 2021 in this case, or whatever year you're watching this in. And then copyright holder would be your name. So just like this. This will be your license. And lastly, we have your setup.py. So setup.py, I'll provide the link in the description box where you can go get this code and then you can change these specific tools. But basically, name is PyZix. So you change this to whatever your module name is. The version is 0.01. Whenever you update your module, that would change, your version would change. You have an easy description right here where you can get the README and changelog texts, who the author is, what the author's email is, the MIT license, because that's the license we're using right over here. And then any keywords, and then if your module, like mine, relies on another module, in this case math, then you can just include it right here so that whenever somebody does pip install, in this case PyZix, it just installs math automatically, which you don't need to install because it's already in the Python library. So since it's already in the standard library, since it's not a third-party library, I can just remove that and we should be good to go. Okay, so now it's finally time to install Twine onto our computers so that we can begin to upload our library to pip. So the first step is to go to pip's website and create your own account. Pip's website is pypi.org. So once you do that, you can create your own account. The installation process, or the account creation process, is very simple. Once you do that, you are all set to go. You do have to verify your email in order to create an actual library, and then you're all set. So once we do that, you come to your terminal and you run the command pip3 install setup tools Twine. And once you do that, it runs and installs Twine onto your computer. And then we need to navigate to the folder with the Python library in it. Okay, so once we've navigated to our folder, if you do ls, you see everything that's in there. So we see PyZix. Now there is a problem that I didn't think we would encounter, but we do encounter, and that is that my my library name is already taken, right? So instead, I changed it to PyZix hyphen Vishnu Mano, and then just change this to PyZix hyphen Vishnu Mano. This is just to keep everything organized, but this name is already taken, so that's why I did PyZix hyphen Vishnu Mano. Okay, so once we finish that, we should be able to just upload this through Twine. Whoops, okay, so first we have to set up sdist. This basically adds a folder called dist to our code. So now if you do ls, you can see dist right here. This is not something we created, as we saw up here. This didn't exist, but now it got added, and then we can lastly do this Twine upload. So we enter in our username and then password. Okay, great. It finally worked. I know I probably edited it out, but I've been trying this for like the past 30 minutes, so I'm very excited that it worked out. If we go to Google and enter in that link that was provided to us here, view at, then we see we have our own pip module, right? PyZix hyphen Vishnu Mano. Anybody out there who's watching this video, if you type pip install this, just copy this. I'll put a link to this in the description box, but if you just copy this, then you can install my library, which is really cool to think about because I've been programming with Python for a couple of years now, and I've always seen these libraries, but making my own is definitely very crazy. So very excited that this happened. So we've published to pip. That's amazing. So there you have it. You can see that now PyZix you can download onto your own laptop, and you can create your own modules by yourselves. So there we have it. We've finally created our own module in Python to help researchers or other developers use physics functions in their programs. So thank you so much for watching, and I'll see you next time. Bye.